Hey everybody, it's Norm from Tested here, and today I'm going to be reviewing Bambu Lab's newest 3D printer. They have yet another one. This is the latest in their A line of printers. The A series previously had the A1 Mini, so cute, really great entry-level printer. The A1, which was a great workhorse of a printer, and then this big guy. It's the A2L, A series, second generation, large format printer. It's really interesting because across Bambu Lab's three lines of printer now, A series, the P/X series, and then the H series, they've really covered all their bases. And so I was surprised that they didn't refresh the A1 and did something interesting, maybe made it a dual extruder or kind of revamped the design. They went with the H series build volume and build size, but in a bed slinger form factor at a really interesting price. But let's recap what a bed slinger is. So this gantry-based system is what houses their extruder. And this is fundamentally the same new generation of extruder, a servo-based extruder that we saw with the H2S. And I believe it's exactly the same as the primary extruder in the new X2. There's so many lines of printers now. Well, that means it's a servo-based one. You get feedback in the filament extrusion, and that feedback in that encoder lets the system dynamically control at high speeds the extrusion of that filament, which reduces the variances in the print quality and also can help detect things like clogs or printing in air, and it's just a smarter extrusion system overall. It's still a bed slinger design, and so the x-axis and the z-axis are on this gantry, and everything is scaled up, of course. And the y-axis is on this bed slinger, so it goes up to the front. And of course, with all bed slingers, you gotta make sure you have enough clearance in the front, about 5 inches or so in the front, in the back, about 3 inches or so in the back, and it's all open air. So as opposed to having an enclosed build volume, like you found in the P series, the X series, and the H series, you're primarily going to be printing filaments that are PLA, PETG, and yes, it can do TPU if it's dry enough, but not things like ABS or engineering filaments where you really want to have a controlled, heated build volume. And in fact, the build plate here, while it does heat up suitably for those basic filaments, it only goes up to 80 degrees Celsius, which is 20 degrees less than 100 degrees Celsius that the previous A1 printers. And I think that's just a factor of it being that much larger a build plate and the power draw being a strong consideration. The build plate is an interesting size. It's not quite swappable with the H2S or the H2D, but it is very close to those build plates in size, much larger than this standard build plate. This is what we saw with the A1, the previous P series, and the X series, that classic 256 by 256 millimeters. That's 10.5 inches square. This one is an interesting 330 millimeters wide by 320 millimeters deep, so that's over a foot, and it can print up to 325 millimeters high. Again, over a foot in each dimension. But the larger the build volume, the bigger the things you're able to print on a bed slinger, the stronger consideration you have to put into the stability of those prints. At a very fine layer height, of course we did our benchy test, everything turned out fine, but at a very fine 0.08 layer height, I printed this Notre Dame Cathedral, and the details are all there. I did have a little bit of stringing, and that could have been just the filament not being dry enough and needing a little more retraction in my settings. But on the front facade of Notre Dame, with no supports necessary, all the details there and no layer shifting. Very nice resolved detail on about a 26-hour print. I also wanted to test the height limit of this printer, and so printed this Eiffel Tower. This is in PETG, so a little higher temperatures, and this reaches that 325 millimeters, that about a foot in max print height. And the tip of that spire, which I'll admit in this model did snap off due to my kids, not due to the printer, the layers are all perfect. Like you can just see these layer lines, there's no shifting, and this is what you'd be most concerned about when you're printing in open air, reaching those max heights. The printer is moving really fast, the nozzle and extruder is moving really fast, and I see no shifting even in this really delicate area of the shroud that goes over the dome of the Eiffel Tower. Really, really impressive with the max height. This gives you a reasonable sense of like the tallest thing you can print. Most of the time, you're not printing this tall. With a large build plate, you might be printing a lot of objects, just maximizing the number of individual things you can lay out and arrange on the build plate, which is, and mostly printing, if you're printing miniatures or small trinkets, you're never really going over a couple inches. But at this size, and with the size of an H2S or H2C, we're really moving into larger than hand props. And one test I always love to do is like, what's the biggest kind of helmet you can print? And so I had Adam's shop assistant, Alex, send me his breakdown of this Ralph McQuarrie designed Darth Vader helmet. And this is 4 pieces, but this is a fully wearable helmet split in 4 really large pieces. In fact, the top shroud, the top dome of the Vader's helmet maximizes basically it's the biggest thing you could print on this build plate, printed flat on each surface. And even though, if I'm looking at this, even though these are actually oriented in 2 different directions, the front of the helmet oriented this way, the back of the helmet oriented this way, in both dimensions, at least from my eye, it's a pretty darn near perfect print. There's no visible sign of layer shifting, of wobbling. It is really, really clean. I mean, obviously, if you're going to put a coat of primer on this, you're going to want to sand this because you're going to see some stepping as it reaches the peak of those designs. But even the front of the mask, the gorget here, everything just worked out really perfectly. And this is the kind of size of a thing that you can print when you have a printer with this build volume. I know a lot of people have A1s that they've been really happy with, but this 10.5 inch by 10.5 inch does become restrictive. And while you can split a helmet into parts that let you assemble into a wearable piece, once you get double that actual volume of what you can print, you can actually start putting things out in fewer than half a dozen pieces that become wearable. This was really, really impressive to me. The other features that I really like is that it's a pretty quiet printer. Bambu's algorithms and motor calibrations and vibration calibrations and compensation has reached a point where even when printing at full speed and the bed is moving and the nozzle is just going back and forth, I feel like this printer can operate in a living space, in a working office at home, not just relegated to the garage where you don't want to hear the printer. And that's where I feel like they're aiming this printer to be, in homes and in maker spaces, and honestly in schools. Because one of the most interesting things that this printer can do that the A1 series previously could not do is it also can be used with Bambu's cutting module accessory. And so I want to show you exactly how that works. So remember in the H series of printers, the extruder had an attachment, an optional attachment that let it be used as either a laser cutter or a vinyl cutter / pen plotter. Obviously, this being an open air system, it's not going to work as a laser cutter, but it can use that exact same cutting module, which is this guy. This is a $70 module, and it comes with this, a blade, a pen holder, and a cutting mat. And with the cutting mat being the same size as what you'd find in the H2S, it means that you can cut things that are basically a foot by a foot. It's a really easy attachment that you pop off the front, you pull off this dial. It's the same system as you would use to install it on the H2S, and it just slides in front of the extruder. There's a power and data port in the back that gets plugged in. And once that's plugged in, the system knows that it's in the cutting module mode. And we lock this in place, and then here you can plug in one of 2 accessories. The default one is the cutter. So this is a fine blade that just gets slotted in here. It can freely turn, and you can use this as a vinyl cutter. So we've demonstrated in the past cutting stickers, cutting vinyl that you can apply to windows. You wouldn't be laser cutting PVC, so you don't have to worry about that kind of toxicity. And the thickness of materials you can cut go up to 0.5 millimeters, 0.5 millimeter. It's not the thickest, but it still can cut like thin leatherette veneer, not full leather pieces like for badges or luggage tags, but things that you can then adorn onto other craft projects. But more interesting to me is its ability to also be a pen plotter. Because if the idea is that this printer is great for households, for schools, printing is cool, but kids love plotting, love watching the robot draw something. And so to make this a plotter, we take this 3D printed tool, pull out the blade, and we swap it with a pen holder. Haven't seen how this is used? It's really simple. There's a sleeve that either a marker or a pen can fit in. It comes with a standard marker. 10.5 diameters is the maximum. But what I found is that users have created sleeves themselves, inserts that you can plug in that go on top of here. And that will let the sleeve fit something like this Sakura Micron 01 pen. This is a 0.25 millimeter diameter pen. That can go right in here, and it's important that you calibrate it to the height. So this is exactly how far the pen should go. We do a little bit of a tightening, pop this off, and that gets popped right in there, and now it becomes a plotter. We of course then swap out the build plate. This comes off, and with the cutting module accessory, you have a grip plate, still magnetically attaches, and it's double-sided. There's light grip and there's strong grip. Light grip is plenty strong. This gets popped in here. We peel off the protective plastic covering, and then you can put whatever material you want, whether it's felt, fabric, leatherette, veneer, or cardstock. Paper works okay, but because of how strong this grip material is, I found that paper sometimes tears, or even when you're able to pull it off, it kind of curls up and becomes less usable. So kind of cardstock, standard cardstock is a great way to make use of this as a plotter. But we pop this on and lightly tap it just to have it tack on. And then you can use Bambu Lab's Bambu Suite software to import images and vectors. And they have a pretty nice tracing feature. So you can upload what I found is like coloring pages or line art, and it will vectorize them, turn them into a path that then you can use your pen, your marker to draw. You can select multiple colors within that program so that the G-code will automatically tell the plotter to stop and let you swap up pens. So you can have multicolor images, and you can use it to make things like greeting cards or all sorts of stationery. Now, you might be asking, isn't this just a fancy way of printing out a color page? Like I could send a vector or graphic to a laser printer, a color printer, an inkjet printer, and get a nice page. And that's absolutely true. But there's something really magical about watching a 3-axis machine hold a pen and draw over the course of the plot time a complex image. And I got to do everything from simple drawings of San Francisco. These are just free vector art that I found online that my kids love to turn these into coloring pages, and watching it draw, to more complex pieces like this map, vectorized map that took about 3.5 hours to draw, and almost becomes a little bit of a art installation in of itself to watch this pen for 3.5 hours draw out a fully vectorized map. And that's just scratching the surface of what you can do with this, because if you put a marker in here and you set the diameter, you can also have the program fill in a drawing. And it's interesting the way it does that. For example, here, this drawing of a baby Pikachu, the fully black areas were the pen, the marker, actually line by line filling in those dark spots, and then at the end drawing the outline. It's not a perfect piece of software. There are things I wish it could do. For example, when you trace an object or you maybe download a vector drawing, a lot of them, sometimes the strokes that you see are not individual lines themselves. They're outlines. They have both an outer edge and an inner edge. And when you upload that image, that vector, to the Bambu Suite software, it wants to draw both that outer line and the inner line. So there's nothing in the software that allows for a center line stroke analysis of a traced image or of a vector drawing, which I would love for it to do. It also, when it fills in these drawings, it does it kind of like an inkjet printer. It goes line by line. And I would love for it to do it a little more randomly, do a crosshatch pattern in its fill, or color it in a different angle, just to mix it up and make it look a little more hand-drawn. But everything from the slight bleed of the marker to the pressure of the machine actually drawing on physical paper or material or cardboard or any type of material you want to put on here, it just has a nicer feel than sending this to an inkjet or laserjet printer to print out. Having a lot of fun with it as a plotter. And I think a lot of people will too, bring this into schools, into the home. There's room definitely for improvement. There's no bird eye camera on the extruder. So H2S has a system where it can pre-align images, so you can print a photo and then it'll know where to cut out. Here, there's no way to pre-align it. You have to use your phone, and they're still working out the kinks on how to actually get the phone to work with their software to pre-align its drawing. And the webcam is a 1080p webcam, but it's low frame rate and not as nice quality as the ones you find in their higher end printers. But all of that's to say that the A2L enters the market at a really competitive place and price. There's a lot more competition out there. I really like the Snapmaker U1 multi-tool head printer. That felt like a great entry point into multicolor 3D printing. And while the A2L has a combo option that comes with the AMS Lite, I feel like with a single extruder, single tool head, there's gonna be so much waste filament that you get with the purges and the prime tower that I wouldn't really recommend this for large multicolor prints. This feels more suitable for single color prints that you can then fit together in an interesting way. And so you can fit standard 1 kilogram spools, and I think there's a missed opportunity for Bambu to include a 5 kilogram spool holder or incorporate a 5 kilogram spool dryer, like a version of their AMS HT, but made for larger spools. That would have been a really cool thing to launch with the A2L. But it comes in at $470 without the combo, without the AMS Lite, and then $570 if you want the AMS Lite. And my recommendation is spend that extra money on the cutter module and the plotter option, because at 70 bucks, I feel like that's a real no-brainer accessory to get with this. I was given some indication that the price they were considering even a closer to $400 price, and at 400 bucks, this would have been such a great price point for this product, a no-brainer, an astounding price. You have the A1 Mini at about $200, the A1 you can get now for $300, and if it was really $100 more for this size, I would absolutely get this over the A1. At $470, it does get close to what the P2S costs. That's $550, and so you kind of have to choose between bigger build volume but more limited filaments that you can use, but more functionality potentially with the cutter module, or the P2S, which works really great as an enclosed printer with more engineering filaments, but a smaller build volume. The software for Bambu Suite, I think, absolutely could use more updates and more improvement. And that's a long way of saying that software is hard. And one of the reasons that Bambu Lab has been so successful in the past couple of years is because their software has been pretty rock solid. And a lot of that software, as some people out there, as you might know, is off the backs of what Prusa and their team did with the Prusa slicer. Bambu Studio is a fork of the original Prusa slicer code that was made public under the AGPL license. And you know where I'm getting at. There's been a lot of controversy lately with Bambu Lab making it clear that they don't want third-party developers taking the code that has been put out as part of Bambu Studio that taps into their Bambu Connect and their cloud services. They don't want people putting that as a part of their third-party software, whether it's part of the AGPL license or not. It's clear that they want that to be a proprietary thing. And they made that clear, I think, last year when they announced the changes to their terms that if you want firmware updates to their printers, you need to be able to be locked into Bambu Connect. I'm okay using Bambu Connect. It's how I've always used these printers. I'm happy to use Orca Slicer, happy to use a third-party slicer if I want to run these in LAN mode, and I'm happy for the folks who run machines that way. Bambu, in an interview, they wouldn't deny that they were in the future going to lock features behind subscription plans or take features away. And that would be a line that if they crossed it, I wouldn't be okay with. I'm happy to recommend these printers now because how well they work and how many people have enjoyed using them. But if they ever get to a point where features that we normally expect from buying hardware today get taken away because they're then put behind a paywall, then we're going to have to change our evaluation of that. But as of right now, for this price point and for the way it operates, this is a really nice improvement over the A1. It's not what I expected from them going with a larger bed slinger, but now they have a printer at $200, $300, $470, $550, all the way up to the many thousands with the H2C. Let me know what you think about this size, and if you have an A1, if this is something that's interesting to you, and if you have an H2S, if you make use of their cutter module and the plotting module. I'm having a lot of fun with this one. My kids are as well. Thanks so much for watching. This is the Bambu Labs A2L. Pre-order is available today. We'll have more information and links in the description below. Otherwise, I will see you next time.